Hello everyone. In this lecture we're going to take a look at ratios and proportions and how we use the two of them, how we convert them, how we reduce them. You're going to see a lot of overlap in this lecture between what we talked about last week with fractions, because a ratio is essentially a fraction, though there will be some differences that we'll get to in a little bit. So first, let's start with what is a ratio. Ratio is two unrelated things that are compared using numbers, which is very wordy and kind of abstract. So think about what this might look like in real life, where you might see two unrelated things compared using numbers in real life. An example might be something like the speed limit. That's a ratio. What's the speed limit out on I-25? Like the actual speed limit if there's a cop around. But like 65 miles per hour, 65 miles to 1 hour. Other ratios that you see a lot in real life. What's the current price of gas right now? Pretty cheap. I mean, it's going back up, but I haven't paid, less than $2 for gas in ages. About $1.59, $1.59 to 1 gallon of gas. If we were actually in the classroom together, maybe we could say we have 2 male students to 3 female students. Or we could say that we have 5 students to 1 teacher. These are all examples of ratios. We're taking two things that are not related in any way, like what is the connection between miles and hours, for example, and we are comparing them using numbers. There are a few different ways that ratios can be written. You can see them written, what we see right here, 65 to 1 with a little colon. You can also write them as a fraction, 65 over 1, or you could just write out 65 to 1. All of those would be acceptable. Now, because we can write ratios as a fraction, we can also reduce ratios like a fraction. And I want to make a little disclaimer here. Even though we can treat ratios like fractions, they are not fractions. We can have decimals in ratios. We can't have that in fractions. So there's a lot that you'll see that's similar. There's some stuff that you'll see that will be different. So let's take this guy here, 250 to 100. We can rewrite it as a fraction, 250 over 100. And hopefully some of you look at that and say, but wait, that's an improper fraction. It is an improper fraction. Should we convert it to a mixed number? And this is one of the places where ratios and fractions deviate. We don't have any mixed numbers in ratios because we always have to have only 2 numbers. So no mixed numbers in our ratios. But we can reduce this 250 over 100 like we would a regular fraction. So think of a number that goes into both 250 and 100. How about 50? They can both be divided by 50. We'll divide top and bottom by 50, like we would a fraction. And we'll get 250 divided by 50 should give us 5. 100 divided by 50 should give us 2. So there we go. We have our fraction reduced down to 5 over 2 or 5 to 2. Either one would be an acceptable answer. Oh gosh, what if we have fractions instead? We're comparing 2 fractions in our ratio. We can reduce these as well, and we reduce these by simply sticking a little line in between our dots and turning this into a division problem, into our copy dot flop of fractions lectures long ago. So if you remember copy dot flop, we copy down the first fraction, turn the division into multiplication, and the second fraction, sorry, I'm getting ahead of myself. turn our division into multiplication, the second fraction gets flipped on his head. And then you multiply. 3 times 5 is 15. 4 times 2 is 8. Now, of course, once we're done with that, see, can we reduce 15 over 8 down any more? Is there anything that goes into both of those numbers? And there's not. So 15 over 8 or 15 to 8 is our final answer. Just like dividing fractions, if you have mixed numbers, say we had instead of 3/4, say we had 1 3/4 to 2/5, this would have to become an improper fraction before we do anything else. We'd have to turn it into 7/4 to 2/5 and then divide. What about if we have decimals, 0.3 to 3? There are a couple of ways that you could approach this. The way I like best is just turning both of these numbers into fractions and dividing from there. So 0.3, this is 3/10. 2, how do we write 3 as a fraction? How do we write a whole number as a fraction? We stick it over 1, 2, 3 over 1. And then we would divide. Copy, dot, plot. To get 3 over 30, that can be reduced. We can divide top and bottom by 3 and get 1 over 10. Or 1 to 10. So that's a ratio. What about then proportions? What is a proportion? Well, a proportion is two equivalent ratios that are set equal to each other. This is the same as our equivalent fractions. If you remember from the little fractions review that I sent out, I had this big long list of equivalent fractions to 1/2. 1/2, which is the same as 2/4, which is the same as 3/6, or 5/10, or 10/20, or 25/50, or 1,000 over 2,000. All of those are equivalent fractions. They're all 1/2 of something, just written in different formats. So how do we know if we really have a proportion, if we're given, two numbers set equal to each other? The nice thing about proportions is their opposite corners will always be equal. We should be able to multiply 4 times 3, and we should be able to multiply 1 times 2, or 1 times 12, sorry, and they should be equal to each other. So let's check real quick. 1 times 12, and we are going to set that equal to 4 times 3. Hopefully you're seeing this already. So 1 times 12 equals 12. And then 4 times 3 also equals 12. So yes, this is a proportion. 1/4 and 3/12 are equal to each other. Let's look at another one. We have 1/5 equals 3/10. Let's do that. So we would multiply 5 times 3, and that should be equal, if this is a proportion, to 1 times 10. So 1 times 10, and set that equal to 3 times 5. Well, 3 times 5 is 15, and that is equal to 1 times 10, which is 10. So is this a proportion? No, because 10 is not equal to 15. Right? So this is not proportionate. So this ability of us to be able to multiply the two corners of a proportion and have those two corners come out equal is really, really useful, because this is how we solve for missing numbers in a proportion. And we do this using a technique called cross multiplication. This is unspeakably useful for you to know. If you are not familiar with this technique, I would spend a lot of time practicing it. If you're not sure how to, come and see me. I can find you some resources that will help. You'll see this ad nauseum when you start to do dosage conversions in your other classes. Okay, cross multiplication. Let's look at our problem over here. We've got 3 over x equals 21 over 35. Cross multiplying is a 3-step procedure. Our first step is going to be multiply your corners, just like we saw in the last slide, and set them equal to each other. So we have over here x times 21, that's corner number 1, and then we have 3 times 35, which is corner number 2. So 3 times 35, and we will set that equal to x times 21. So that's step 1. Our second step then, we want to actually finish that multiplication. We can multiply 3 times 35. We can't multiply x times 21 just because we don't know what x is. So we'll do 3 times 35, which is 105, and set that equal again to x times 21. It's very important to just keep bringing down your problem as you go through cross multiplication. Don't try to do any of this in your head. You have more important things that you have to worry about in there. So we finished our multiplication. We know that 105 is the same as x times 21, whatever x is. So now we need to figure out how are we going to find our x. We have 105 equals x times 21. How do we get x by itself? It's multiplied to something. What is the opposite of multiplication? Well, the opposite of multiplication is division. So we should be able to divide by the number that's multiplied to x in order to find what x is. So third step here is to divide by the variable, or divide by the number multiplied to the variable, sorry. You say, what the heck is a variable? The variable is our missing number, our mystery number. The variable is this guy here. So if that's the variable, we are going to divide by 21. So we'll have over here 21 into 105, or 105 divided by 21. So how many times does 21 go into 105? It goes in 5 times. 5 times 1 is 5. 5 times 2 is 10. Subtract 0. There's our answer. This is our x. And we should be able to substitute that in. We should be able to say, okay, then given our properties of proportions, we should be able to do 21 times 5 equals 35 times 3. And they should be the same. And they are. They're both 105. Always pays to double check your work. Let's look at another example. 36 over 48 equals 3 over x. The x is in a different position in this problem. It doesn't matter where it is. The properties are still the same. So let's do step 1, cross multiply. So 3 times 48, and we're going to set that equal to 36, or x times 36. Okay, let's finish our multiplication then. 3 times 48, which is 144. 144 equals x times 36. Again, just bring your problem down with each step that you complete. All right, we've got our problem set up. What is our next step? We need to divide. Divide by the number that's multiplied to our x. So for step 3, we have 36 into 144. 144 divided by 36. And our answer here is 4. 4 times 6 is 24, carry our 2, 3 times 4 is 12, plus 2 is 14, subtract and get 0. So here is our answer. And again, we should be able to substitute this in for our problem. 36 times 4 equals 48 times 3. They both equal 144. So we know that we have a correct proportion. Let's look at another example, this one with some fractions in it. Usually when I put this up on the board, I can hear all my students sort of suck the air out of the room. It looks scarier with fractions, I will definitely admit that, but we're doing the exact same technique. We just have to remember everything we talked about last week with our fractions. So first step, multiply your two corners. So we'll have 1/2 times 12. Remember, we write a whole number over 1 to make a fraction, equals y times 1/3. And then we will complete our multiplication. 1/2 times 12 over 1 gives us 12 over 2 equals y times 1/3. And then after that, our next step is to divide. Remember, divide by our number that's multiplied to the variable. So here we'll have 12 over 2 divided by 1 over 3. And this is our copy dot flop. 12 over 2 times, flop our second fraction on his head and get 3 over 1. 12 times 3 is 36. 2 times 1 is 2. Now, we can reduce this. We can make this down into a whole number, 36 over 2, by dividing 2 into 36. Again, your fractions are coming back to haunt you. 2 goes into 3 one time. Subtracting get 1, bring down your 6. 2 goes into 16 8 times. So our final answer is 18. Y equals 18. How about this one? Now we have decimals instead of fractions. There are a couple of ways that you could do this. The way that I think is simplest is just to convert your decimals into fractions and then multiply or divide from there. So 0.4, how do we write that as a fraction? Well, remember, everything to the right of the decimal is your numerator, and then the denominator is the place value of the last number. Our 4 is in the 10th place, so this would be 4 over 10. What about 1.2? Well, again, everything to the right of the decimal is your numerator, so we have 2 in the numerator. The last place value of our decimal is the tens place, and then don't forget that 1. And now let's turn our mixed number into an improper fraction. So 10 times 1 is 10, plus 2 is 12, all over 10. Now let's plug those in and solve our problem. So we have 4/10 over 12/10 equals 1 over x. First step, multiply your corners. So right over here, 4/10 times x equals 1 times 12/10. And then 1 times 12/10, any number times 1 is itself. So we'll have 4/10 times x equals 12/10. And then to solve for our problem, we will divide. Divide by the number multiplied to the variable. So 12/10 divided by 4/10. And this is where we'll do our copy dot flop. 12 over 10 times 10 over 4. Well, 12 times 10 is 120. 4 times 10 is 40. So we have an improper fraction here. We can reduce this and get a whole number. So to convert from an improper fraction to a mixed number, We do the denominator on the outside, numerator on the inside, and divide. And 40 goes into 120 3 times. 3 times 40 is 120, subtracting it 0. So our final answer, x is 3. Let's look at one more. This one also has a decimal in it. We have y over 16 equals 0.75. Well, again, the easiest way to start with this would be to convert our decimal, our 0.75, to a fraction. And probably you know this 0.75 is the same as 3/4. So now we can rewrite our problem. Y over 16 equals 3/4. And then from there, we'll cross multiply. 16 times 3, y times 4. So 16 times 3 equals 4 times y. And then finish our multiplication. 16 times 3 is going to give us 48 equals 4 times y. And then to finish, we'll divide by the number that's multiplied to our variable. So 48 divided by 4. 4 goes into 4 once, subtracting it 0, bring down your 8. 4 goes into 8 twice. It gives us 8, subtracting it 0. So our final answer is 12. Y equals 12. And remember, you should always be able to re-enter your numbers, cross-multiply, and get the same answer to test if this is a proportion. Let's do that here. So if we have 12 over 16 equals 3 over 4, we should be able to multiply both of those corners together. 12 times 4 equals 3 times 16, and these should both be the same number. 12 times 4 is 8 and 4. 3 times 16 is 18, carry your 1 and 4. So 12 times 4 is 48. 3 times 16 is 48. They're both the same number, so we know that our answer is correct. Always make sure that you're double checking your work as you're going through your problems. Takes all of 5 seconds to plug both of those numbers in the calculator, but it's definitely worth it when you're saving your grade. Let's look at this a little more practically with a word problem. You are at, I don't know, UC Health. And for every 12 patients that you have in the hospital on the floor, you need to have 4 nurses, in case like you need a crash cart or someone codes or someone falls down and goes boom. Today you have 60 patients on the floor. Y'all are busy. How many nurses are you going to need to pull out of the break room to help you with all of your patients? Well, up here we're given our first ratio. For every 12 patients on the floor, you need 4 nurses. We could write that, 12 patients, 4 nurses. We could also write that 4 nurses to 12 patients. Doesn't matter which one you pick. We'll go with the one on the left over here. What does matter is when we set up the second half of the equation. So 12 patients to 4 nurses. Today you have 60 patients. It's a bad day in the ER. How many nurses do you need? Well, we don't know how many nurses we need. We do know that we have 60 patients. And this is key to setting up cross-multiplication problems from a word problem. You want the same units to be on the same half, either top or bottom. So patients with patients, and then we'll have down at the bottom nurses with nurses. Okay, how many? We don't know. Let's find out. So step 1, cross multiply. 60 times 4, 12 times x. $60 times 4 is 240, which equals 12 times x. And then we'll do our division. How many times does 12 go into 240? Well, 12 goes into 24 twice, because 12 times 2 is 24. Subtract and get 0, bring down our 0. 12 goes into 0 0 times. So for all our 60 patients, we need to go find 20 nurses to keep them all corralled and in line. Another example, this is where we get really practical. So this is remdesivir, which I think you heard me talking about in the respiratory system lecture. This is the drug that they are currently experimenting on, seems to have really, really good outcome for COVID-19. You are working at I think they're doing an experiment with it at Swedish. So you're at Swedish now. You get around a lot. And you are told to go dose up a patient with remdesivir. The label for remdesivir is 100 mg for 5 milliliters, which means that for every 5 milliliters of medication that you pull out of that bottle, it has 100 milligrams of the actual drug in it. Your patient needs 350 milligrams of remdesivir. How many milliliters are you going to give to your patient? This, like I said, is where knowing cross multiplication comes in really handy for doing your dosage conversions. Now, I always have some student who's like, Myth, don't they have a computer program for that at work? And they do, but in the zombie apocalypse, you're not going to have a computer program. So we're going to learn how to do this by hand. So let's start with our label. 100 milligrams per 5 milliliters. We can write that as a fraction. It is kind of written as a fraction. Let's write it as a fraction we can work with. 100 mgs per 5 mils. And our patient needs 350 milligrams. Where are we going to write that 350 milligrams? On the top or on the bottom? We're going to write it on the top over here. Keep your like labels together. Milligrams on the top, which means milliliters will be on the bottom. And milliliters is our variable, our mystery number. That's what we're looking to find out. How many mils are we going to dose our patient with? Okay, we have our problem set up nice and pretty. Let's go. Multiply your corners. So 350 times 5 equals 100 times our mystery number. And then after that, you'll do your multiplication. So 350 times 5 is 1,750 equals 100 times our mystery number. And then we're going to divide that by the number multiplied to the variable, that guy there. So 100 on the outside, 1750 on the inside. So 100 will go into 175 once. It'll give us 100, subtract and get 75, bring down your 0. 100 goes into 750 7 times to get 700. Subtract, we get 50, add a decimal, add a 0, bring your decimal up into your answer, bring your 0 down. How many times does 100 go into 500? Well, 5 times. So your patient who needs 350 mg of medication, you're going to give them 17.5 milliliters of remdesivir. So hopefully this has been a nice quick refresher for you about what you do with ratios and proportions. If you have questions on this, or if you would like more problems to go over, or if you just want to chat, stop by office hours and we can go into further detail.